you get on there, you look through all the flats, you find the one that's exactly in the neighborhood you want with the right number of bedrooms and it's affordable, and oh no, you call and it's not available anymore. This is a frustrating experience. You feel like you wasted your time. So the problem the product team cared about was, how can we know when a flat is rented, because the broker's not going to necessarily call us and tell us, as soon as possible, so we can take it down so nobody sees that flat when it's not available. We're not showing something to people and teasing them and then not letting them actually have the option of renting it. Okay, so then we would look like all kinds of data again at this problem. We'd look at, for instance, what does the number of successive calls an owner receives? What's the pattern between that and how often they'll answer it? So this graph here shows on the y-axis the average percentage of calls not answered by owners. And on the x-axis is the number of successive calls to owner. So you get your first call. What percentage of the time do owners miss their first call? And then their second call, and then the third call, and the fourth call, right? You can imagine your owner, you list your flat, you're waiting, the phone rings, you're sure to answer it because you want to rent your flat. Maybe by the 20th call, you're done. You're like, I'm going to give this to a broker, or you've rented it. And so you start to miss the call a lot more, right? So your percentage goes from 40% of the time missing the first call. By the time you've got 20 calls, you're missing around 60% of the time. So we can look at how many calls this flat has gotten and then use that to predict whether the flat is available as one predictor, as one data point. Okay, so the thing is, we're looking at actually a very similar problem from two different perspectives. We have two different needs. One is getting a flat off the site as soon as possible, and another is getting the number demasked as soon as possible to save. And what we realize is that a lot of times you can be if you're operating where you're just answering one question for one person and another for another, right? You're losing the opportunity to bring resources together and use the same methods to solve multiple problems. And those two problems weren't even our main problem. Our main problem was how to find the valuation of a flat. Okay, so let's just return to the sort of the breakdown and actually make it a little more concrete. So our main problem was actually, how do you find what a house is worth? Everyone wants to know that, right? An owner wants to know that because they're the one deciding the price, and they want to know, right, what's the right price that I can set this at so it'll actually get rented. And a looker doesn't want to spend any more than necessary. So the first impulse is, okay, I'm going to go solve the problem of valuation. Okay? But valuation is actually a big question, and you should be asking small questions. Okay, so what small questions? Well, valuation is composed of things like how many bedrooms, square footage, how many bathrooms, the layout, right? All these things, and that's the aspects of a house. But you can have a really nice house that's way off in the country or in a terrible neighborhood, and its value is much lower. So it's also about the value of the neighborhood around the house. How many restaurants there are, how many ATMs there are, what are the services, how close is it to the center of the city or the business district. Okay. And then there's all these sort of intangible factors, like does it have a sea view? Is it just a really cool neighborhood at the moment, and all the up-and-coming artists or what have you are moving to that neighborhood? You can't even evaluate that with things like ATMs or restaurants. You might be looking at questions like, how much, if you buy this house, how much can you get as a rental yield? So what can you rent it for? Because you might be buying it as an investment property, and you want to be able to rent it out. So when we're solving the problem, in order to know how much a house is worth, you need to know what people think it's worth. So you need to estimate the demand for that house and the demand for the locality that house is in, right? So we were solving those problems, right? And as you solve them, as you find out how long a house should be masked, you've got an indicator that says, oh, it should be masked for 20 days. That means 20 days is about how long it'll be on the market. And what happens if you bring the price down? How many days is it on the market? Or bring the price up? How many days are you expected in addition for it to be on the market? And all of this is about breaking that problem down, solving the small ones, and then moving back up. Not starting with the very first question you get. That's usually way bigger than it's possible for a machine to do very well. Okay, so now I'll give some examples from where I am now, which is, like I said, is a financial technology startup. It's called PaySense. And what we do is create financial experience kind of for our users. And the first product, and we're not very old, just about a year. And the first product we give is actually small loans, personal loans. Okay, this graph kind of gives you kind of a good intro to the kind of problems we're solving using machine learning. So what this graph shows is the scores, is the view of our customers from the perspective of a credit rating agency. I don't know how many of you have bought a house or have taken a loan, but there's an agency in India called CIBIL. And CIBIL provides scores, and most conventional lenders, most conventional banks, NBFCs, use this score as a way of assigning you a credit line, telling you how much you can borrow, okay? So this graph along the x-axis is your scores, and CIBIL scores range from 300 to 900. And the purple line here on the right is the distribution of users that CIBIL publishes as ones who are typically lended to by large banks and NBFCs. Okay? And you can see so the median is around 800. So most people being lent to are 800. And it gets down to around 700, but it doesn't go much below that. Banks just don't want to engage with those users, right? So you can see the blue line is the distribution for PaySense users. And you can see it's considerably left shifted. So we're looking at a different market, a market that's a little bit lower on the scale. And you can also see actually up on the top, right, 16% no CIBIL and 26% new CIBIL. So that's about 40% that don't even have a CIBIL score. Okay, so how do we understand this population when they don't look like the normal population that's being lent to? And you can look at different things here, like, okay, this is actually what's called a bimodal distribution. That means there's two humps, right? And usually when you see two humps, that indicates it might be actually two different populations you're dealing with. So when you're looking at how a population is distributed, you've got two, and there's some other features that are going into this that are kind of telling you these two groups of people are separate along some indicators. Maybe it's income, maybe it's how much they spend, maybe it's how many loans they take out in a given year. So this is our problem. This is the kind of thing we're trying to identify is how do you understand what a user's ability to repay a loan is, how much they can afford. Okay, and it's also an optimization problem. So these graphs, I'm sorry, the resolution here is not very good, but hopefully you can at least see the two lines. Again, on the x-axis we have CIBIL scores. On the y-axis we have two y-axes. And on the left here, this plot here, we'll start here. On the left side is a delinquency percentage. And it runs from 0 to around about 7%. So that means the percentage of people who aren't paying us back. Okay? And on the blue axis, which is on the right side of the plot, is the loan count. So this is from a sample of loans we've given, right? And the thing you're trying to optimize, the task you're trying to solve for is lending money, and the performance measure is how much you get paid back, but also how much you're lending, because you can't really make money on 100 loans. You need to be lending thousands of loans, hundreds of thousands of loans. Now what this shows is that typically, if you want to decrease your delinquency, you want less people to not pay you back, right? Then you should put a threshold. You should expect your users to have a score of a certain amount. Okay, so if we start from the very far left, if we say our minimum score is 450, right? Then we're going to see a delinquency of about 7%. And as we increase the threshold, you'll see at some delta, the delinquency goes down to where if we have a score around 700, it's around 1%, less than 1%. Okay, So that's great. So you say, shove it all the way up. But the other measure you're looking for is actually lending to people. And that's the blue line. That's the number of people you can lend to if you have that threshold. So as you increase your score limit, the number of people you can lend to goes down, right? So what we're trying to do, the performance measure is to keep the red line as low as possible while keeping the blue line as high as possible. And you can see, so you can slide your number, your threshold, your score minimum, up and down that scale and watch how the blue line goes up and down. Okay. This is a pretty standard task for machine learning. But you still are juggling different performance measures, and you're still thinking about what the right one is for you as a business. Okay? Now, I'm going to step back from examples for a minute and go back to a higher level of thinking about how does an organization learn to do this kind of thing. So when we're making these decisions, we're also trading off between how much does a machine make the decision versus how much does a human make a decision. So in India, a lot of conventional lenders, banks and NBFCs, they actually have humans. They have human risk managers who will evaluate your entire loan application and will decide to approve or reject it. And we're trying to go to the other side of it because that's very expensive and it's also a little bit subjective, and maybe people have different prejudices and different ways of evaluating you that's maybe not optimal. And most of the time the risk manager doesn't really even know what the right measure is. So you can move and say, nope, we're going to make this all about data and we're going to make machines make the decision. And a lot of times, this is what an organizations will think. They'll think, let's do machines. You've read the latest piece about artificial intelligence, and it's going to replace, displace all our jobs because we're going to put all those risk managers out of work, and we're going to have machines make all the decisions. And this is the same problem as trying to tackle a big question. Remember, we tried to tackle a big question and it doesn't really work, so you break it down to small questions. Similarly, displacing humans is setting yourself up for failure in machine learning. A better way to think about it is how your machines support your humans and how your humans can modify their behavior in order to support your machines. So this is kind of the way we think about it, is you say, okay, as you have a very bad score, you can auto-reject, right? Your machine can kind of make that decision. It's fairly basic. It's fairly clear. They're spending way more than they're making, and they've not paid back their last 2 loans. Easy decision. No sense having a human look at it. And then you've got a really good person who they save, they've always paid back, and they're only borrowing a little bit in comparison to how much they're making, maybe to buy that new air conditioner a little faster at the beginning of the summer so they can survive. Right? And that you can auto-approve. You don't need a human to look at that. It's pretty straightforward. Those are the easy ones. The hard ones, the ones where everyone gets wrong, the ones if you can do right, you have a great business, is the ones here in the middle, right, where it's not quite clear. It's not quite clear whether the person deserves that loan, or maybe they actually save a lot, but there was an unforeseen medical event in their life, right, and that just caused a cost. And they're going to recover if you can give them a chance, but you don't know. You can't look into the soul of every person who fills out an application. So there, you can say, I'm going to use data and machine to kind of guide, and then use your human to look at those decisions and say, wait a second, our machine made a complete assumption or completely missed this other variable. And then you can have a feedback loop where you say, you know what? We're completely missing this other feature, and we should think about how, as an organization, we can modify the way we're evaluating things to turn that feature, that aspect of that applicant, into a piece of data that can go back into the decision, update it, and begin to not miss that as much. So this is a approach where you have machines and humans working together, and it's a lot more promising than just pure, let's automate it and lay off all our staff. Okay. And a lot of times this happens through this iterative process. I want to be careful about time, so maybe I'll I'll skip through this one. So the other thing is, though, is that a lot of times you say, if I can answer my question well, and then you're like, you build a model and you start to answer your question well, and then you're like, great, the job done. I figured out how to approve loans. I figured out how to figure out who's able to pay me back or not. And that is an example where you're stopping too soon. Okay, so when the traditional view is exactly this: you make a decision when a person makes an application, can they pay me back or not? You make the decision, then you give the money or you don't give the money, and it's done. And if you give the money, all you have to do, you sit back and you watch and you see whether they repay. And if they do, great. And if they don't, oh, maybe you can fix your model, right? And that's one way of looking at it. But another way of looking at it is that actually your machine can kind of do this, your models can do it in a much more iterative and ongoing way, and you can actually say, can I actually construct an experience, financial experience, or whatever value as a business you're providing, that can actually change the probability or the likelihood of someone repaying me? So instead of just predicting and then sitting back and waiting and seeing, you can say, what can we learn based on this model that can help us do things a little bit differently, construct the instrument, the financial loan we're giving in a way that